using a ray diagram to locate and describe an image that's formed by a lens. Now what I'm actually going to do, because the chapter in the tank doesn't have a good example to use, I'm going to use the same example as it has in chapter 17 of the tank for concave and convex mirrors. So I'm going to do it for a convex and a concave lens. So example 1 says there's an object of height 1 centimetre placed 6 centimetres in front of a concave mirror of 4 centimetre focal length. So let's do that. First of all, draw your principal axis very carefully and neatly. All right, so we start with the principal axis. We mark the lens in the centre. Now, if this was, if the lengths I had to draw were bigger, I would have to use a scale drawing. So let me just pick a spot for the lens, and I'm just going to draw a line through the centre. Now, I'm going to mark the shape of the lens. It's a converging lens. I'm not going to try and draw that correctly with the right curvature. It's just ridiculously hard. But if you just mark it to remind yourself what you're doing, and we're going to bend the light rays at that vertical line. So, 6 centimetres, 4 centimetres. So the focal length is 4 centimetres. Because it's a lens, I'm going to mark the focal length and the centre on both sides of the lens, because I'm going to need them on both sides. The object is placed 6 centimetres in front, so it's here, and it's 1 centimetre high. There's my object. Where is the image going to be? Well, we're going to draw 3 rays, just like we do for curved mirrors. The first ray goes from the top of the object across to the line and then bends so it goes through the focal point. I'm trying to get this neat and accurate. 1, 2, 3, 4. There. Draw as precisely as you can. Actually, I suspect I need to go a bit further. The next ray goes through the focal point on the object's side. Oops, my pencil moved. And then we'll bend at that point to go out parallel. And already I can see where my image is going to be. But if you want to make sure, you can draw the third ray, which goes through the centre of the lens and is not bent at all. Okay. That ray is going like so. So my image is going to be, now if I'm right, I think it should actually be here. I'm just looking at my drawing to try to figure out whether it was my inaccuracy that did that. There's my image where all 3 lines meet. So, my image is real because the light rays actually converge at that point. If I put a screen there, you'll see the image. It's real, it's inverted, upside down. It's 12 centimetres from the lens, 12 centimetres on the far side of the lens, and it's twice as high.